doing it yourself, that's fine. First step, factorise the bottom of this one. If you factorise that, you get x minus 6 and x minus 2. Right backwards. To make this all the common denominator, this one needs to be multiplied by that. So we've got x minus 2 over plus this one needs to be multiplied by that one. So we've got x times this is where often people get to and then decide they need to expand all the brackets. We just don't need to. We're just going to take, we either multiply through by all of this, or we just know that if I did that logically, I would then be able to say that x minus 2 plus, let's do x squared minus 6x, so I can collect like terms, has to equal 4, right? Which then gives you x squared minus 5x, let's subtract the 4, so that's minus 6 equals 0. With us? You were there at that point, no? And then obviously to solve a quadratic, we factorise. In this case, we get x plus 1, x minus 5. No. Minus 6. Therefore, potentially solutions are x equals negative 1 and x equals positive 6. But from this line up here, we can state that x is not allowed to equal 6 and x is not allowed to equal 2. Only one of those needs to be taken into consideration at the end. So that is not a possible solution. So my only solution is that. Now, let me ask you this question. What would be the consequences, or the consequences of solving this using technology? Well, I don't need to factorise to. Let's have a look. This was that. Can you tell me what the equation is again? Because obviously I haven't got it on my screen. The whole thing from the very beginning. The very first line, the question. What is it? Hang on, chill. X divided by 2 equals x squared minus 8x plus 12. Okay. All right. Negative 1? Yeah, that's why it, I can't click on it for whatever reason. Won't let me. Yeah, so we got that. That other solution, obviously, over here is not something that is applicable to the entire thing, is it? Right? It was a solution to our simplified form, but actually, sorry, I've done something completely stupid and wrong here. That's my solution. That's not what I wanted to do. Let me just, if I want to solve equations like that, I need to put it under here, don't I? Let's see whether I can. Right, now I'm talking. Sorry. So what I'm looking for, look, is where the blue side equals, if I make that y equals, it doesn't change anything. Where does the blue side equal the black one? And you can see that we've got one there, which is at -1, right? And we have another one. Well, we don't look. Look what happens at -6. It's an asymptote. Yeah? So actually, using technology, you would have, in this case, seen exactly the same thing. All right? Because it looks like the blue and the black are equal, but they're not, are they? If we were to zoom in, the closer you get, look, the bigger that gap gets. So you can see, all right? The further out it looks like they cross, they're never going to cross, and it is at that 6. So using technology, all right, you get that one solution, but the other potential one you think is there is not. Where was the other not possible solution, which turned out not? It was at 2, and look what's happening at 2 as well. There's another asymptote, but they're coming at it from either side. It's quite cool, the graph, isn't it? Yeah. Why the what? Which one are you talking about? So that's what that rational function looks like. Why does it behave in that way? Well, hopefully you realize, like, this one is, as if you put x in, if x goes higher, you get a fraction that gets smaller, yeah? And as it goes negative, you end up with a different behavior. Yeah? So this is why you kind of get this kind of behavior. What does it look like? Do you recognize this kind of wave shape from any other function? It's not the same at all, but the tangent function has this kind of, you know. This one, why does this one come back down rather than this one go up? What behavior is it in here that would... But also it has x squared, yeah? So what's the results of squaring things in a function? Your negatives get affected, so that's why we have this shape, all right? So yeah, but we have our asymptotes at 2. For this one, for instance, why is it an asymptote at 2 and 6? Yeah, when you factorize this one, they're the two things. In the same way, those ones have the same 2 asymptotes. It just behaves differently either side of it. And then when you put them together and you want to know where they're equal, obviously asymptotes, we share an asymptote, but we do have one where it equals. Right, so we've just gone through that. Look, the checking was just putting the -1 in and checking that the left-hand side equals the right-hand side. Right, simple enough. So